So my last example is this example, e to the x sine 2x. And for this example, this is an example with an annoying trick. You'll see when we get there. You may not like it. I made the 2x in there to make it look a little bit different. I think in the book they have e to the x sine x or e to the x cosine x. Those are anything that's e to the ax sine bx or e to the ax cosine bx, it's going to be this mess that we're going to do this time. So occasionally they show up. So it's good to have this in your back pocket. Remember what to do if something like this happens. But it's really only ones of this form where this is going to happen. So with that, let's just go ahead and start. I'm going to let u be my e to the x and dv be my sine of 2x. So du is this e to the x, dx, and v I integrate, right? So I'm going to have 1/2 cosine of 2x. Wait, the derivative of cosine is negative, sine, so I have to minus. Okay? It's important to get these minuses and pluses right. So what do I have in my first step? I'm going to have minus 1/2 e to the x cosine 2x minus the integral of, okay, negative 1/2 e to the x cosine 2x dx. Okay, so I'm going to cheat a little bit and not rewrite this. I'm just going to change these guys to pluses. And for my ease of mind, I'm going to pull this 1/2 out there. Okay? And I'm just going to go ahead again and do the same thing. Okay, let me do it this way. Let me write the u's and the v's up here. I want to keep the same pattern as we said. So u is going to be, is that, you guys can see that? Okay. U is going to be e to the x, and then the dv is going to be cosine 2x, and then du is going to be e to the x dx, and then v is going to be sine of 2x. I'm going to get a 1/2, right? Okay, so now if I put this in here, this piece stays the same. Plus 1/2 times uv is going to be 1/2 e to the x sine 2x minus the integral of v du, which is going to be 1/2 e to the x sine 2x dx. And now it's like, what? Because I just did it twice, and I got back exactly what I had to begin with. So that's like not good, right? If you went back and redid it, which I'm not going to do, but did u being sine and dv being e to the x, the same thing would happen. And it's because both of these are like that, right? E to the x is just e to the x each time. It's not going to change. It's not like x squared, which goes down to x and then down to 1. E to the x, it's always going to be e to the x. Sine goes sine, cosine, right? But you're saved by the fact, remember I said something to make sure we get the negative right. You're saved by the fact that it doesn't just go sine, cosine. It goes sine, cosine, negative sine, negative cosine, right? So, in fact, yeah, that looks the same, but there's a minus here. So, let me write this a little bit better. So what we can do, let's first rewrite it and get all our constants together, or at least worked out. So this is going to be plus 1/4 e to the x sine 2x, and then this is going to be minus 1/4 times the same integral we started with. Right? So this box is the same as this box. So that's the problem, but it's a minus 1/4 here. It's not a plus 1, and that's going to save us. What we can do is we can add that integral to both sides, like the whole integral. Well, which also now that seems weird. So let me rewrite this. Let me do this. Let me get rid of this part. And let me sort of rewrite this sort of in this way. So I'm rewriting this equals that, but I'm trying to make it a little bit smaller. So whatever's in the box, I'm going to let it equal big I. Big I for integral, right? So let big I be this integral, e to the x sine 2x dx. That's what we're trying to solve for. We're trying to do that integral. So if I rewrite this, I have I equals whatever this stuff is here, plus 1/4 e to the x sine 2x minus 1/4 I. Okay, I don't know if that's too small. That might be too small. So maybe it would be, well, let's just leave it like that. Is that too small or not? Maybe you can just zoom in. All of this, these are these two terms, and I just have I equals this stuff minus 1/4 I. So what I want to do is I want to add 1/4 I to both sides, right? Maybe I'm just going to throw that guy over here, right? And what I end up with, which is already a nice piece here, these guys then cancel, and I have 5/4 I equals all this garbage, which you can write equals garbage, but you can just write it properly like we should, right? Plus 1/4 e to the x sine 2x. And then what I can do is I want to solve for I, so I just multiply the whole thing by the reciprocal of whatever coefficient that is. It happens to be 4/5, right? So then I've got I being on one side, and then my answer is going to be over there. So let me then just put it up here because that's what my I is. So after multiplying through by 4/5, I am going to have minus 2/5 e to the x cosine 2x plus 1/5 e to the x sine 2x, and I got to throw a constant at the end. Okay, so that is the trick. As I said, it's not a very pleasant trick because it looks kind of weird, like you're adding the whole integral to the other side. You don't have to substitute I for the box, for the integral, if you don't want. I do it that way because to me it's a little bit less messy to add I to both sides than to add this box integral to both sides. But really, it's up to whatever you want to do. If you look at the example they did in the book, I think it's very similar, but it doesn't have the 2, so then you don't have these coefficients. Most of the examples that you might be doing with this, where you would have this where it comes back to itself, would end up having that coefficient in there. So, yeah, I like to do an example with at least one number. The more numbers, of course, the messier it's going to be. So if I did like e to the 3x sine 2x, you can imagine it gets pretty hairy with all those coefficients. This, at least, only the one coefficient, it's sort of okay. But if you want to look up some more examples, definitely there's ones in the book, and I'll see if I can find you another one online that has the same thing happen.